Please welcome Detlef Mennerich, Global Head of Boehringer Ingelheim Venture Fund and jury member of Falling Walls Venture.
Good morning. I can't do this. Impressive. So it's my great privilege to be here today and honored to reflect on a day on Thursday where we saw 25 amazing concept companies addressing sustainability, technology of the future, computing, and life science. And there were 25 winners, but we as a jury, and I'm on behalf of the jury of Stefan Holzbrink, we had to collect one winner. And the winner is Lumai. And I would like to invite James to come on stage. He will address the future computing we all need, energy efficient, to address all our AI ambitions. James, the stage is yours.
The number one limitation on AI capability today is not data, and it's not models or their algorithms, it's energy. We've got to the point where hyperscalers are reopening nuclear power plants just to provide the energy needed to power AI data centers. That's ridiculous, and something needs to change. So why have we hit this energy wall? Put simply, the better computing resources you have access to, the better AI capability you can build. And so historically, we've scaled our energy capability, our computing capability in two ways. One is just making our processors faster. And that means squeezing more transistors onto a piece of silicon, onto a chip. We've got to the point where there are billions of transistors on each chip, and each transistor is only a few atoms across. Again, that's remarkable, but we can't keep doing that forever. So we've gone the other way. We've scaled out instead. So we now have these data centers that have tens of thousands of processors hooked up, interconnected, to perform our AI capability instead. That's essentially brute forcing the problem. And we can't keep doing that for much longer. So we need to be smarter about it. We need to rethink the underlying technology. And that's what we're doing at Lumai by using light to perform processing rather than electronics. So that means building an analog physical system of components to perform the computation, using photons rather than electrons to encode the information. Now, there are some fantastic advantages to doing this, and it all comes down to the fact that it's an analog process, and we can fundamentally encode information as a physical process rather than turning it all into zeros and ones and shuffling it around with transistors. Now, I say the operations for AI. What do I mean by that? Well, the genius of modern AI and deep learning is it's really simple arithmetic. It's just multiplying and adding numbers, but in immense scale. So the operation that we actually need to perform for AI is matrix vector multiplication. And it's a structured form of adding and multiplying numbers together. So how do we do that using light? Well, we first need to encode the matrix, which is just a whole bunch of numbers, into a physical display. Something like the screen of your phone, where each pixel represents one number. We encode the vector with an array of lasers, where the brightness of the laser encodes the number, and we pass those laser beams through the display, and that performs the multiplication. We then combine the lasers with lenses and with optics, and by combining the lasers together, we perform addition, and we then detect the output of that result and turn it back into a digital signal. That's pretty cool, and the fantastic part is that it's passive. As the light propagates through your system, you're not using any energy. So it sounds pretty amazing. It sounds like it's free computing. It's not quite that simple. We still use energy generating the light. We still use energy decoding the signal, turning it back into digital. But the 3D geometry of the system gives us a really unique property. So we want to get faster, right? Faster computing means better AI. And we do that by scaling up the system, adding more light beams, adding more pixels to our display. And as we get bigger, the number of operations we perform, the number of multiplies and adds, scales with the area of the matrix. So as we get bigger, we do more operations, and we get better AI. But the amount of energy we use scales with the input vector, which is linear. This is really unique? It means as we get bigger, we get faster, but we also get more energy efficient. That's completely unique. You don't get that with silicon, with digital, or anything else. So that's the science. And what are we actually building at Lumai? We are building AI acceleration systems based on this optical multiplier. They're completely standard form factor systems, so they look like normal compute servers, normal compute racks, but they have this optical multiplier at its core. And based around that, we can achieve massive speed up compared to digital systems, whilst only using a fraction of the power. And that really is what we need to overcome this energy wall. These are clearly artist impressions. The technology is real. So in the coming months, we'll be releasing our first demonstration system, which consists of two key parts. So one is this actual optical multiplier itself. So it's a system of optics, lenses, displays that performs this matrix vector multiplication operation. And the second is custom electronics, digital and analog electronics, which is responsible for pushing data through the optical multiplier and interfacing with the rest of the system. Add some specific software layers on top of this, and we have a complete AI acceleration system that can perform some of the biggest language models to date. Now, why do we need this? Well, we've been talking with potential partners and customers across the entire AI value chain, and the message is remarkably consistent. The gap between what we need in AI capability to perform all the amazing operations and applications we can, and the performance that we can actually get from modern hardware, that gap is huge and it's growing, and there's a desperate demand for something radical to change that. I obviously need to give a huge thank you to our team. We're based in Oxford in the UK. We have a fantastic team of all sorts of different engineers that have been and built technology for new markets across precision optical instruments, AI chips, all the different layers of the software stack, and they're just a fantastic team of people to work with. I also need to give a massive thank you to our partners and our backers. We have a global consortium of investors trying to tackle a global problem, and definitely wouldn't be possible without them. Final few comments. We are growing. We still have open positions available. We're a startup, so obviously we're fundraising. If you're a VC, please let me know. If you want to find out more about whether, why energy is a limitation to AI capability, about the demonstration system that we have coming up in the next few months, or you just want to know how we do maths with lasers, please reach out to find out more. Thank you very much. Thank you.